Chapter 5, Number 50. A 5-kilogram bag of potatoes sits in the bottom of a stationary shopping cart. A. Sketch a free body diagram for the bag of potatoes. And B. Now suppose the cart moves with a constant velocity. How does that affect your free body diagram? And explain. So, our bag of potatoes would be this. And we know that inside the cart, let's put it inside shopping cart. So we know that we have the force of gravity, because that always acts on it. And we have a normal force holding it up, keeping it not going through the bottom of the shopping cart. And then that's it. That's everything that's in contact. Since the bag is stationary, then there's no tendency to slide against the shopping cart, so there's no friction. So that's A. That's all there is. And then B says the cart moves with constant velocity. How does that change your free body diagram? The answer is it doesn't change it at all, because there are still no horizontal forces. There's no need to explain the push as it moves forward. It wants to keep moving forward. So it will keep going forward, basically, if something were to give it a constant velocity. You might think, but really it should slow down. It would slow down if the cart were left to its own devices and had to slow down, then the bag would slow down. But if you had the cart and it was, say, motorized and moving at constant speed, then there would be no tendency for the bag to slide on the cart, and there'd still be no friction. The key thing in either case, really, is that the net force in the x direction is the mass times the acceleration x direction. And since that's 0, the force is 0. So there are no other forces up here. If we physically needed another force, we'd have to add it and then balance it somehow. But right now, there's no force that's calling out to us, so this is it.